everyone. Today we will be building a RAG-based chatbot step by step, right from scratch. By the end of this video, you will have your own chatbot that can answer questions using the data ingested by you. To build this chatbot, we will be here using some powerful but beginner-friendly tools. So, beginning with, we will be first using LangChain. It will help us to stitch everything together. Then we will be using Qdrant as our vector database, an E5 embedding model to turn the text into numbers, Mistral 7B as an LLM which will act as the brain of the chatbot, FastAPI server, so you can actually run your chatbot as an API. So in this video, we will start with a simple version so you can see it working quickly, and then I will show you how to upgrade it with Airflow. Airflow will be used here to automate the ingestion part and make it production ready. Here is everything you need to install first. It looks like a lot, but it's just a few minutes of copy paste. So let's first start with the Python packages. So first you need to install some of the basic Python packages that will be needed to build this RAG chatbot. So as in your LangChain, Qdrant client, sentence transformers, fast API, and many other packages. So let's just first install these packages. Here I am installing these packages in my virtual environment. So you can create your own virtual environment in the project directory. So as you can see here, I have already installed these packages into my virtual environment. So that's why it's showing as requirement already satisfied. So now let's move to our next requirement. Here we are done with installing the Python packages. Now the next requirement is to have Qdrant vector db. So for this I will be running this Qdrant vector db using my Docker. So now let's just do it. I am running my Docker command to get my Qdrant container. Okay, so it's there. You can also verify it running by going to port 6333 in your local host. So here you will be seeing your Qdrant welcome page, and like in the collections you will see at this point of time we don't have any collection. So that's fine. Now we are done with having our Qdrant container. Then we have verified our Qdrant running fine on our local host. Now the next step is to have our local LLM, which is Mistral. So you can install it locally through Ollama. So first you need to download Ollama. So based on your operating system you can download it from here, and then once you are done with installation of Ollama you just need to pull Mistral from there. Let me pull my Mistral. So here as you can see it has pulled, and I now have my Mistral there into my local machine. Now let me show you how the project looks like. This is my project root directory, and here is my .env file which contains the secrets and the configurations that are needed for my RAG chatbot. So here you can see the Qdrant URL. So as you have seen earlier as well, it's running on localhost on 633 port. Then I'll be passing my Qdrant collection name as this RAG POC. Now I'll be passing the doc URLs which I will be ingesting into my Qdrant vector db. So at this point of time I am ingesting the Qdrant documentation and Mistral documentation. Now to use my Ollama model, which is Mistral, I am passing these further two more configurations. Let's just go through these packages. So first is this app package. Into here, the first module we have is this embeddings E5 module. So this is here using the model E5, which is actually a great sentence embedding model. And here you can see in these functions we are passing in a tiny prefix as passage or query, which you can see like it actually represents the passage, represents the chunks that we will be storing into the quadrant, and the query is for user queries. So like, and we are also normalizing the embeddings here so that the cosine similarity works well. Now coming to the ingestion part. So here we will be taking these web pages link from the doc URLs, and then we will be turning these web pages into some useful little chunks. Here, as you can see, we are fetching the pages and then cleaning the HTML. After cleaning the HTML, we will be going to this build index module. So here we are finding the smart boundaries with a semantic chunker and then applying a small 20% overlap so we don't cut important sentences in half. Once done with chunking and creating the embeddings, we will just go and upsert our embeddings into the quadrant vector DB. Now let's run the build underscore index module to ingest our data into our quadrant DB. So I have put on this command and it will be ingesting my data. Let's wait for a few minutes. Now, as you can see, it has run and it has created 14 chunks and also upserted those into the quadrant DB. Now let's just check into our quadrant as well. Let me go to the collections and see if my collections are created. Okay, so my collection is created and it has those 14 chunks. Let me go into it. Here we can see all the chunks that are being inserted, and in this chunks you will also see this metadata associated with it. So here you can add more keys as well, which will help you achieve your fine-grained access control as well by putting in the keys, defining the access levels, as in if this chunk is confidential or is it publicly available, or you can also define like whether this chunk can be accessed by a specific department within an organization. So these kind of things you can manage using this metadata. Now coming to the serving part, which is our fast API, which will help the users get the answers for their queries. So what it will do is, so this is my API exposed, and then behind the scenes what it is doing is it will be actually retrieving the relevant chunks from the quadrant DB based on the user query and will then be returning it back to the user using our LLM, which is Mistral here. So let me show you the code which is being returned to do this. So this is my function which is returning my Ollama LLM here, which is the Mistral over here. And then this is the retriever, which helps retrieving the appropriate chunks from the quadrant. And then further on, once we have retrieved those chunks, we will be passing them into our prompt. So the prompt will be containing the user question and the context, as in the chunks that we have retrieved from quadrant, and passing this prompt to the LLM. LLM in response will be returning the proper answer, which can be then sent back to the user. Let's run the fast API server now and test our API. So now I am just running our fast API server. I am using here Postman to test out my API. You can use curl command as well. So now I am putting my API, which is having the method post, And in the body, I'll be putting in my query as JSON, and then I will just click on send. Let's just wait for a few minutes. This is how my response looks like. So the API returned the response in the JSON format, having keys like answer and sources. So in the answer key, I will be getting the answer to the user query that was asked, and in the sources you can here see which all sources it used to get this answer from. So this is how my API works on. And then, like, if you want to create a chatbot like UI, you can create it using Streamlit and then integrate this API to get the answers of the user queries. As you have created the RAG based chatbot, you will be able to relate to this architecture very easily. So here the top box is ingestion, which starts with documents, which are the same that we had in our chatbot code as doc underscore URLs, which contained the document links. So after we grab the documents, which were web pages in our case, we will break them into the chunks, as in some understandable pieces, and then convert each piece into a vector, which are embeddings, and save them in vector DB, which is Qdrant in our case. Next is the serving box. So it will cover the FastAPI serving part. Here a user asks a question, and then our retriever pulls the top k chunks from the vector DB, and then the prompt assembler will assemble those retrieved chunks and user query in the prompt and pass it to the LLM, which is Mistral in our case. And finally, LLM returns the answer back to the user. So now here you will be thinking, why not directly return those retrieved chunks to user rather than using LLM here? So to understand this much better, let's go back to the output of our API. So here, as you can see, it's very difficult to get a straight and understandable answer from these chunks. So that's why, like, as we use the LLM, so it just returned us the answer in a very understandable format. So that's why we use LLM here. Here in the output of my API, you can see the answer returned as well as the sources as well. So the sources here are actually the chunks that are stored in my Qdrant vector DB. So by seeing these sources as in these chunks, it will be very difficult to get an answer in a very straight and understandable format. But here, as you can see in the answer, the returned answer is actually very understandable format. So that's why we are using LLM here to generate the answers in a very easy and understandable formats rather than searching them in the chunks on our own. Right now, our chatbot works, but every time if I change or add new pages, then I have to run a Python script manually to re-ingest the data. And it's very painful if you have to do it very frequently. So that's why I will be now using Airflow here to automate this process. So now I am just going to first install Airflow. Now I am making a directory to for my DAGs, for my logs and my plugins. Now I will be putting in some environment variables. So this has created .env file with these variables. Now I will initialize Airflow. The above command has been run. Now I am just running my next command. Finally, my Airflow is up and running. Let me just see in my browser. At 8080 port in my local host, it's running. Let me try to sign in. So here you can see I am able to see a lot of DAGs over here. So it's running fine in my local host. Returning back to my project directory, I have created a new directory named as DAGs, into which I have created my DAG module, and my DAG ID is rag ingest tag. So what this will be doing is it will be doing the same job which earlier my build index pipeline was doing, which was chunking, embedding and upserting to Qdrant. Now let's just return back to our Airflow in my browser and see if this DAG is there or not. Let's just search for my DAG. So here, as you can see, there are no results for it, and this is fine as well, because to be able to see my DAG over here, I need to first mount my repo into the Airflow. So let's just do it. I just went into the directory where I have downloaded my Airflow. So here, as you can see, I have this docker compose.yaml file. So now just open this file and put it our configurations to mount the repo into Airflow. Edit the docker compose.yaml file for Airflow, and here in the services you just need to go to Airflow web server service and add this volume section over here, and do the same thing for the services Airflow scheduler. Add the volume section here for this service, and then again for Airflow worker as well. Like this, I have added this volume section. Now let's just save it and run our docker compose down and up command. First, I will run the compose down command to stop my already running container of Airflow. It will remove it as well. As you can see here, it's removing them. So you have to run this command from the folder where you have your docker compose.yaml file of Airflow. So now, as you can see, my existing container has been removed. Now I'll be running the compose up command to create the container with my new configurations that I have done to mount my repo. Let's wait for a few minutes. My compose up command has also ran. Let's first check if my DAG file is there or not in my Docker. So just verifying the mounts. So yes, I can see here it is there. So let's go to the UI and see how it looks. As you can see in the Airflow UI, here it's showing as DAG import errors. Let's expand it to see what's wrong. It's broken DAG this. Let's expand further. Okay, so it's saying as module not found error, which is for LangChain. So now we need to actually install this package. So this package is missing here. So let's have a fix for this. Now I have created two files. One, the requirement files having those package requirements that are currently needed in the Airflow to import my DAG file, and the next is my Docker file which will help me building that custom image. So let me show you what's in there into this requirements file. So here, as you can see, we have these packages which are actually needed for my DAG file, and then you can here see how my Docker file looks like. So it's just copying these requirement files and then doing a pip install. Let's configure our Airflow to use the custom image that we are building using the Docker file, which actually has all those requirements in which are needed for our DAG file. So here, let's just come to this docker compose.yaml file for Airflow, and into the services in this Airflow web server, just add this new section for build. Here in the context, we will be passing in the directory where we have our Docker file stored. So here in the Docker file, I have passed in the name of my Docker file, and the same build section we actually need to have in the other services as well, which is Airflow scheduler. Like this I have added, and the same I have added in Airflow worker as well. So like this. Now let's just go and run our compose down and compose up commands. I have also added the quadrant configurations as well here in the environment section. Here you just need to pass in the quadrant URL, collection name, doc URLs which you want to ingest, chunk words, and the overlap for the chunks, which is 20%. Now let's just go and run the docker compose commands. I have run my docker compose down command first to stop my existing container, and then I did this compose up command passing in the build parameter. So here it will be building up my image as well. Here you can see it's just running this command of pip install and also copying up my requirements file, and further on it my container for Airflow is now up and running. Let's just go into the UI and see if my DAG file is now there or not. In the browser now, I am not seeing the previous error that was coming up regarding the importing the my DAG file, which was due to the missing module. So now let's just also verify it by searching over here if I can see my DAG. Okay, it's coming up here. Perfect. So now my DAG file is there in the Airflow. Now let's just try to trigger it and see if this works or not. So if I trigger it, ideally it should be fetching my documents, splitting them into the chunks and embedding them and then upserting them to the quadrant. Let's see if it is doing this or not. So let's go to this trigger button and I'm just clicking on it. Let's see what it will do. Okay, so as you can see, the status is running. On click of this bar, you can see the status of this DAG, as in its current status, when it was started, and how it was run. So like let's wait, and I think it's still running. So if you go here into this small square box, let's me show you. So here it will be actually showing you more in detail, as in you can also see the logs as well. Here you can see it's still running. Let's just wait for a few more minutes. Now the state has changed to success. Let's just go and see in the logs. So here you can see it has created 14 chunks, and then upsert is also complete. Let's just go to quadrant and see. So this is my previous upserts that were done manually. So those were 14 at that time. So now since 14 more chunks are added, so it should ideally be 28. Let's just refresh my screen. Okay, perfect. So it is now showing 28 chunks. So this is how Airflow helped me to ingest these points, these documents actually, without running them manually using the Python commands. Further on, you can actually add the script to trigger the Airflow only when there are new, let's say, documents are added into your defined ingestion path, or if only there is a change in the existing documents. That's a complete beginner friendly RAG. You saw today how to ingest, retrieve, and answer with citations, plus a quick way to re-index while you experiment using Airflow. The code used in this video can be found at this GitHub repo. The same link is mentioned in the description box as well for your reference. So keep learning and keep building. Thank you.